Hello everyone, welcome back to our Python programming course. In the previous lecture, we learned how to work with strings. Strings allows us to store text such as names, messages and email address. But let me ask you a question. Suppose I want to store the marks of 5 students. How should I do that? Let's see. Now we'll create a new file, that is Python lecture 8. So if I write mark 1 is equals to 85, mark 2 is equals to 90, then mark 3 is equals to 78, mark 4 is equals to 88, and mark 5 is equals to 95. This works, but imagine storing the marks of 100 students. Would you create 100 different variables? Definitely not. There has to be a better solution. That solution is called a list. A list allows us to store multiple values inside a single variable. Now, what is a list? A list is a collection of multiple items stored in a single variable. Lists can store number, strings, boolean values, and even different data types together. Now, let's understand with an example and let's see how we actually create the list. So, so this was how we were storing 5 marks in 5 different variables. Now I can store them in a single variable called marks, but in this format. So 85, 90, 78, 88, 95. And then if I write print marks, let's see what happens. But before that, let's comment this out. So let's see. And yes, we get each and every marks. But notice the square brackets at the end. Lists are always written inside square brackets. The values are separated by commas. Now let's see different types of lists. A list doesn't have to contain only numbers. Like here, if you see, we are just storing numbers in our list called marks. Now if I write fruits is equals to apple, banana and mango. So can we store it like this? Let's see. So before that, let's comment this out. Now if I write print fruits, let's see what happens. So the output is apple, banana, mango. Now similarly, this is the output similar to the one we got for marks. So from here we can get that in a list we can store strings and each and every kind of data type. So we have seen we have seen storing strings and numbers in our list, but let's see if we can actually store boolean values. If I write status is equals to true, false, then again true. Let's see the output. If I now write print status, let's see, the output is true, false and true. Now what if I store multiple data types in a single list? So our first data type will be string. Now let's write a number, that is 20. Now let's give boolean, and then we'll write a float value, so 85.5. Let's see if I write print data, what's the output, or will it give error? So we actually get this. Unlike some programming languages, Python allows different data types inside the same list. So you can see here the first element, that is Rahul, is a string. The second one is an integer. The third one is a boolean value, and the last element is a float. Now here, from here we can see that in a list we can store multiple data types. Now pause the video, create a list of your 3 favorite fruits, then create a list of your 3 favorite sports, and at last you can create a mixed list containing your name, age and city. Then print all the 3 lists. Now we created a list, but let's see how to access individual elements. Remember indexing from strings? Lists work exactly the same way. Now let's comment it out. And now if I write fruits, apple, banana, mango, and one more, so that's orange. Now there are 4 elements in the list, but let's see before accessing how it is actually stored. So apple, banana, mango, orange. So these are the 4 elements. Now this is the indexes how it is stored. So the 0th element of the list is apple. 0 represents the first element, the first one represents the second. From here you can understand using. Now if you remember the indexing in string, it was exactly like this. The first character started from 0. So the indexing of the first character was 0, and here the first element is called the 0th element, or the first element of the list. And similarly the indexing of the list starts from 0. Now how to access them? Now let's comment this. And now if I write print fruits and 0. Now what does this actually mean? Remember string 0, if I write 0 and if the variable is here, the 0 gave the output the first character. Now if I am writing 0 for list, it should give me the first element, that is apple. Let's run this, and yes, we are getting the output as apple. Now if I write 1 instead of 0, the output should be banana, and yes, we again get it. And instead of 1, if I write 2, then run it, mango is the output, and if I write 3 over here, I should get orange. Yes. Now this was all about positive indexing, but remember strings? Lists also have negative indexing. So similarly, like lists, the indexing is -4, -3, -2 and -1. Now if you want the last element, you can write -1 over here and you will get the last element. So we get orange. And if I write -3, we'll get banana. Yes, we get banana. Now negative indexing is useful when you want elements from the end of the list. Like right now if I write fruits 10, let's see what happens. Probably we'll get an error, and that's correct. We'll get an index error because the list doesn't have that many elements. Always make sure the index exists. Now predict the output of few programs that I'm going to write. So the first program over here, that you need to predict is numbers is equals to 10, comma 20, comma 30, comma 40, comma 50. And now if I write print numbers 1, can you guess the output? Let's see. The output is 20. Now let's see if I write print, or instead of 1 if I write -2, can you now predict the output? The output should be 40. Let's see. The output is 40. Now remember the len function in strings? What if I use len function in case of numbers or in case of lists? So if I write len numbers, let's see what actually happens. Can you find the length of the numbers? So 1, 2, 3, 4 and 5. So the length of the list numbers is 5. The output we get is 5. So len function is also used in case of lists. It works the same and its syntax is same as that we learned in string. Now so far we have learned how to create lists and access individual elements. But what if we want to access multiple elements together, change an existing value, or add new items to a list? That's where list slicing and list methods come in. Now let's learn this concept. Now we have learned what lists are, how to create them, and how to access individual elements. Now the biggest advantage of a list is that it can be modified after it is created. Let's understand this. We learned that strings cannot be modified directly. Let's see what happens if I try to modify them. Now if I write text is equals to Python, and if I write text 0 is equals to j. So if a string could have been changed, the output of this should be Jython or Jython instead of Python. So let's see if it is possible or not. It should give error and type error. str object does not support item assignment. What does this mean? This means that strings are immutable, which means they cannot be changed after they are created. Now let's try the same thing in list. So fruits is equals to apple, banana and mango. Now I want to change the apple to orange. So if I write fruits 0 is equals to orange, and then try to print fruits, let's see what happens. The output is orange, banana, mango. Unlike string, lists are mutable. This means we can change, update, add or remove elements whenever we want. Now, what is list slicing? Just like strings, lists also supports slicing. Let's understand that too with a small example. Now if I write numbers is equals to 10, 10, comma 20, comma 30, comma 40, comma 50. And if I write print numbers 1 to 4. So let's see what's the output. The output is 20, 30 and 40. Now, do you remember the string slicing? It was exactly like this. So this is the starting value and this is the stopping value of the slicing. So 1. So the index 1 is 20 because again in list the indexing starts from 0 until 4. So 1, 0, 1, 2, 3 and 4. Now actually 4 is not included. The stopping value is not included. The slicing stops just before the stopping value. So it goes till 3. So 20, 30 and 40 gets printed. Now what if I write is to 3 over here? Similarly, like strings, it the slicing will start from 0 till the third one, but before the third one actually. So 0, 1, 2, 3. So will the 40 get printed? No. The output should be 10, 20 and 30. Let's see. The output is 10, 20 and 30. Now instead of 3, if I write 2 over here, so what does this mean? The slicing starts from the second index till the last index. So 0, 1, 2. The slicing will start from 30 and will go up to the last element, that is 50. So the output should be 30, 40 and 50. So the output is 30, 40 and 50. Now pause for 5 seconds and try to predict this output. Then we'll continue with our concepts. Now let's change the number over here. So if I write 5, then 10, then 15, then 20, and let's write 25 over here. Now if I write this, can you tell me what's the output in the comment section? So first let's check the output and then we will discuss it how it actually happens. So the output is 10, 15 and 20. So the starting value or the starting index is 1. So it starts from 10 and the stopping one is 4. So 0, 1, 2, 3 and 4. So the stopping index is 4 but the slicing stops before the stopping value. So it stops at 3. So the output is 10, 15 and 20. I hope you all have understood this. Now, suppose we have a shopping list. Let's create that one. Now shopping is equals to milk, then bread and then rice. Now if I write print shopping, so if I see the output is milk, bread and rice. Now imagine we want to buy eggs as well. Do we create another list? No. Instead we use append function. Now if I write shopping dot append eggs and then try to print shopping, let's see what happens. So initially the shopping list was milk, bread and rice, but using append functions we added eggs as one of the elements in the shopping list. So now if I print shopping over here, so the updated list gets printed, the list becomes milk, bread, rice and eggs. So this is how append always adds the new element but at the end of the list. So if you try to add any element in between or in starting of the list, it is impossible to add with append. Append actually does it. Append actually adds the element in the last part of the list, or say it makes that element as the last element. It makes the data, it adds the element in the last. Now do one thing. You need to create a list of 3 favorite movies and then use the append function to add one more movie. Try this program and I hope you'll get clear about the append function. Now, what if we don't want to add the element at the end? Suppose we want to insert it at a specific position. So can can't we do it? Let's use insert function. So if I write shopping dot insert 1 comma butter, let and then print shopping, let's see what happens. So the output is first the default list, that is milk, bread, rice. Then we appended eggs, so the list becomes milk, bread, rice, and eggs. But now, if you see, we write shopping dot insert. This is the position or the index number we want this element to be added. So now butter we want in the first element as the first element. So as the first, so we want this butter to be in the first index. So the 0th index is milk, and here we can see at the first index butter is there. Now the second index becomes bread, the third becomes rice, and the fourth becomes eggs. So the syntax of insert function is, I hope you all get it, is insert index comma value, or let's say the element you want to add. Insert functions basically inserts the element at the specific index. Now, what do you think will happen if I write shopping dot insert 0 comma sugar if this is what I write? Can you predict the output? Let's see. The output is milk, bread, and rice. Can you predict the output right now? Let's see. So first is the default list, that is milk, bread, and rice. Then we have appended eggs, that is the element is added in the last. So milk, bread, rice, and eggs. Now we had inserted butter in case of 1 in the index 1. So butter comes in index 1. Now we are adding sugar but in the index 0. So sugar comes here, milk becomes the first one, butter becomes the second, bread becomes the third, and rice becomes 4, and finally eggs becomes 5. Now suppose you have already bought bread. Now we want bread to be removed from the shopping list. How we will do that? We will use the remove function, that is shopping dot remove bread, and then if I write print shopping, let's see what happens. See, at the last, bread is removed. Bread is removed. So what does remove function do? Remove function removes an element using its values. Now let's see a common mistake. What happens? Now if I try to remove shopping dot remove pizza, let's see what actually happens. Value error. Why this happens? Because the word or the element pizza is not in the list. So if you give any argument in the remove function that is actually not present in the list, then the compiler gives you an error that is value error. So I hope we have understood this. Now I'll move to the next function, that is pop. Let's see what it does. So pop also removes an element, but it removes using the index and not the value. Now let's see shopping dot pop 2. So let's see. Now if you see, this was the final list we got. So sugar, milk, butter, bread, rice and eggs. Can you see what is removed? So this was the final list. So 2. Now let's actually remove this. Print shopping. Let's see what happens. What's the output? So you can see milk, bread, rice is the default one. Then we added eggs. So eggs was added in the last. Then we added butter, but in the first position. Then we added sugar in the 0th position. Now we are removing the second element. So the second element was butter, and you can see the final list doesn't have butter. So here we can remove the element using its index using the pop function. So if we don't provide an index, Python removes the last element. Let's see what actually it does. So if I write shopping dot pop and then try to print the shopping list, let's see what happens. So if you see, eggs was there in the last, but in the last output eggs is removed. So the last element is removed if we don't give any argument or we don't give the index value. Now what is the difference between remove and pop? Remove removes the element by its value, while pop removes by its index. Remove doesn't return removed values, but pop returns removed values. Now I hope you all have understood, but we'll get this thing clear using a simple example. So numbers is equals to 10 comma 20 comma 30. Now if I write x is equals to numbers dot pop, and then if I try to print x, let's see what's the output. Now let's see what's the output. So the output is 30. Now if I write print numbers, now the output should be, now if I have removed 30, the output should be 10 and 20. So yes, the output is 10 and 20. Now if I use remove over here and then if I write 30 over here, let's see, none. Why? Because remove actually doesn't returns this. Remove doesn't returns the element, but pop does returns the element. So while we were using pop, the 30 was stored in x, but when we are using remove, 30 is not stored in x. So this prints none. But remove actually removes 30, so the final list is 10 and 20. Now we will do a mini project. So you can try this program, that is marks is equals to 80 comma 75 comma 90. Now print original list, then we print marks. Now we add one more number, that is marks dot append 95, and then print after appending print marks. Then we'll change it using the index. So marks 1 is equals to 85. Then print after updating, will print marks. Now marks dot remove 80. Then print after removing print marks. Now let's see first the output and then we'll try to explain this. So firstly, the original list was 80, 75 and 90. Now we appended 95, so 95 gets added in the original list but at the last index. So 95 gets added but as the last element. Now we remove. Now we first update the first the we update now we update the value in the first index, that is 75, from 75 to 85. Now the first index value, that was 75, gets updated to 85, and then we remove the value 80. So 80 was the first element, so we removed 80, and therefore 85, 90 and 95 is my final list. So I hope we have understood what is list slicing, and now we update lists, and we have also understood so many functions, how to add elements in the list, how to remove elements on the list. So we will see more concepts about list in this video. We have learned that lists are mutable. We learned how to add new elements using append, insert elements at a specific position using insert, update existing elements, and remove elements using methods like remove and pop. Now let's learn some more useful operations that are used in almost every Python program. Instead of learning these methods like definition from a textbook, let's begin that we are building a simple student management system. Suppose a teacher has entered the names of students in the order they arrived in class. Let's create that list. So before creating, let's comment it out, and then the list goes like students is equals to Rahul, then Priya, then Aman, and then Riya. Then we'll print students. So what we have written, in the first line we created a variable called students. Instead of storing one value, this variable stores 4 names. Notice that every name is written inside quotation marks because names are strings. Also notice that all the values are enclosed inside square brackets. Now whenever you see square brackets in Python, one of the first things you should think about is a list. Now let's print this list, and now when I run the program, the output is Rahul, Priya, Aman and Riya. Everything is working perfectly. But imagine the class teacher says, I want all the students' names arranged alphabetically. Can we do that manually? Yes. Should we do that manually? Definitely not. Python already provides a method for this. The method is called sort function. Now type the following line with me. So if I write students dot sort, let me explain exactly what this line is doing. The variable students already contains a list. When we write a dot after the variable name, Python understands that we want to use one of the methods available for lists. The method we are using is called sort function. The job of sort function is very simple. It rearranges the elements of the list into ascending order. Since our list contains strings, ascending order means alphabetical order. Now let's print the list again. Print students. Now let's see the output. So the output becomes Aman, Rahul, Riya and Priya. So the output becomes Aman, Priya, Rahul and Riya. Noticed the difference? Originally Aman was the third student in the class. After sorting, Aman became the first element because the letter A comes before P and R in the alphabet. Now here's an important question. Did sort create a new list? No, it modified the existing list. This is possible because lists are mutable. Remember the comparison we made with strings? Strings cannot be changed directly after they are created. Lists can be changed. This is one of the biggest difference between the two. Now let's see another example using numbers. So let's comment this out again and we'll write a new list that is numbers is equals to 40, comma 10, comma 80, comma 20, comma 60. Print numbers. Now if we see the output is the list that we gave. These numbers are clearly not arranged in order. Now what if we use that sort function over here? So numbers dot sort, and if I now try to print the numbers list, let's see the output. So we can see 10, 20, 40, 60 and 80. Again, Python has arranged the numbers from the smallest value to the largest value. This is called ascending order. Now before we continue, I want you to think about something. Suppose the list is already sorted. If I call sort again, what do you think will happen? Will Python produce an error? Will it change the list or will nothing happen? Pause the video for the 5 seconds and make your prediction. Now let's test it. If I write 10, 20, 30 and 40, so we see this is already sorted. Now what happens if we run the program? The output remains exactly the same. Python doesn't produce an error. It simply keeps the list sorted. Now let's move to another useful method. Sometimes we don't want alphabetical order. Sometimes we simply want to reverse the current order of the list. For this, Python provides another method called reverse. Let's understand it with an example. Now, if I write fruits is equals to apple, banana and mango and orange. Now if I write print fruits, the output is the one list that we gave apple, banana, mango and orange. Now what if I write fruits dot reverse? What happens? We'll see this by printing fruits. Notice carefully what happened. Python did not arrange the fruits alphabetically. Instead, it simply reversed the existing order. This is a very common point of confusion. Mango Many beginners think that reverse means rearranging the list in descending order. That is not true. Reverse only flips the current order of the list. So let's prove it once again using numbers. So if I write numbers is equals to 30, comma 10, comma 50, and if I print the numbers list and then we'll reverse the list. So numbers dot reverse, and then if we print numbers, let's see what happens. So the first print statement basically prints the original list, that is 30, 10 and 50, and then after using the reverse function, does it actually reverse in descending order? No. If it were descending order, the output would have been 50, 30 and 10. Instead, Python has simply reversed the original sequence. So always remember this important difference. Sort arranges the value while reverse function only changes their order. Many beginners mix up these two methods. So make sure you understand the difference before moving ahead. Now we'll continue our student management system and learn how to count elements, find their position, create copies of lists and completely empty a list when required. Now I hope one thing is very clear now. Sort arranges the element, reverse simply changes the order of the existing elements. Now let's continue with our student management and learn 4 more very useful methods. These methods are count, index, copy and clear. Instead of memorizing them, let's understand why they exist. Now, imagine you are a class teacher. You ask every student to write their favorite programming language on a piece of paper. After collecting all the papers, you enter the response into a Python list. Let's create that list. So languages is equals to Python, Java, Python, C++, again Python, and then Java. Now let us print that list. Print languages. Now let's run the program. The output is Python, Java, Python, C++, Python, Java. Now the teacher asks, how many students selected Python? One way is to count manually. Python provides a much easier solution. Let's see what the solution is. So print languages dot count Python. The output should be 3. Let's understand why. The count function goes through every element of the list. Whenever it finds the value Python, it increases its count. Finally, it returns the total number of matches. So the answer is 3. Now let's try another example. Now instead of Python, if we write Java print languages dot count Java, the output is 2. Again Python found the word Java twice. Now let me ask you something. What do you think will happen if I search for a language that doesn't exist in the list? For example, let's, instead of writing this, let's copy and then again paste it, and instead of Java I'll write JavaScript. So we know JavaScript is actually not present in the list. So what happens? The output is 0. Notice that Python does not produce an error. Instead, it simply tells us that the element appears 0 times. This is very useful in real applications. For example, counting how many students passed, counting how many products are in stock, counting how many times a word appears in a paragraph. Now let's move to another useful method. Suppose the teacher asks, at what position is Aman sitting in the attendance list? To answer this question, Python provides the index method. Let's create another list. Now students is equals to Rahul, then Priya, then Aman and Riya. Now let's write print students dot index Aman. Let's run the program and let's see the output. So the output is 2. Let's understand why. Remember that indexing starts from 0. Our list looks like Rahul, Priya, Aman and Riya. So the index is 0, 1, 2 and 3. Since Aman is stored at index number 2, Python returns 2. Now let's search for Priya. The output should be 1. And yes, it is 1. Exactly as expected. Now let's make a mistake. Instead of Priya, if I write some name that is not present in the list, let's let it be Rohan. Now were you thinking that Python will return 1, -1 or 0? Actually not. This time Python returns an error. Why? Because the element doesn't exist in the list. Because the element doesn't exist in the list. Unlike count, which returns a 0, the index method expects the element to be present. If it cannot find the element, Python raises a value error. This is a common beginner mistake, so always make sure the element exists before using index method. Now, let's imagine another situation. Suppose the school principal asks you to make another copy of the attendance list. Should we type every student's name again? No. Python provides the copy method. Let's see how it works. So we have our list that is students. Now let's create a copy of this list. So new students is equals to students dot copy. Now if I print new students, the output would be same as the original list. Both lists contains the same values. Now let's prove that they are separate lists. Now how will prove that? Let's write new students dot append current and print original list, and then we'll print students. I'll print copied list. And then we'll print new students. Now you can see that we have appended an element that is Karan into the new students list. So this will prove if the copy function actually creates a new list or does it copy randomly. Notice something very interesting. We added Karan only to the copies list. The original list did not change. That proves that copy created another independent list. Now imagine that the academic session is over. The teacher wants to remove all students before creating the list for the next class. Should we remove each student one by one? No. Python provides the clear method. Let's do it using this example only. So students dot clear. Now if I print students, let's see what happens. Let's understand this carefully. The square brackets are still there. This means the list still exists, but it does not contain any elements anymore. This is called an empty list. Now me now let me ask you a question. Is the variable deleted? No. Only the content of the list have been removed. The variable students still exist in memory. Now let's quickly revise everything we have learned. So count method counts how many times an element appears. Index method returns the position of an element. Copy method creates another list with the same elements. And lastly, clear method removes all elements from the list. Before we move to the final section of this lecture, let's test our understanding. So, you need to predict the output of the code snippet I am writing right now. So, the first one is numbers is equals to 10, comma 20, comma 20, comma 30, comma 20. Now print numbers dot count 20. So pause the video and try to answer. What should be the output? Let's see. The output is 3. Now question number 2. Names is equals to A, B, and C. Now print names dot index B. Can you predict the output? The output should be 1, and that's correct. Now in the next and the final section of this lecture, we will learn some extremely useful built-in functions like len, max, min and sum. Then we'll combine everything we have learned by building a complete shopping list management project. Then we'll combine everything we have learned by building a complete shopping list manager product from scratch. We have now learned almost all the important operations that beginners use with lists. Let's quickly think about everything we have learned so far. We know how to create a list, access elements, update elements, add new elements, remove elements, sort a list, reverse a list, count elements, find the position of an element, copy a list, clear a list. But imagine you are working on a real application. Suppose your teacher gives you the marks of 10 students and to few asks you a few simple questions. How many students are there? Who scored the highest marks? Who scored the lowest marks? And what is the total of all marks? Can we calculate all this manually? Yes. Should we? Absolutely not. Python already provides built-in functions that can do this task in just one line of code. Let's learn them one by one. The first function is called the len function. The word len stands for length. As the name suggests, this function tells us how many elements are present inside a list. Let's create a list that is marks is equals to 75, comma 82, comma 90, comma 68, and the last element is 95. Now, suppose I ask you, how many marks are stored inside this list? You can count them manually 1, 2, 3, 4, and 5. But imagine if the list contained 1000 values. Counting manually would be difficult. Instead, Python can do it instantly. Now, write print len marks. The output should be 5. And yes, it's 5. Let's understand why. The list contains exactly 5 elements. So the len function returns 5. Noticed something important? Len counts the number of elements. It does not calculate the sum of the values. Many beginners confuse these two ideas. Let's prove that. Suppose I change the list as 100, 200, 300. And then let's see the length of marks. The length is 3, not 600. Why? Because there are only 3 elements. Always remember, len function counts elements, not values. Now suppose the class teacher asks, who scored the highest marks? Should we compare every number manually? Again, Python has already solved this problem. Let's go back to our previous list, that is 75, 82, 90, 68 and 95. Now instead of len, if I write max, the output should become 95. And yes, Python checks every value in the list and returns the largest one. That's all max does. Now let's try another example with different numbers, that is 10, 400, 25, 87, 120. Now what if I write print max? What if I write print max marks? Let's see the output. The output should be definitely 400. Noticed that the numbers were not sorted. Even then, Python correctly found the largest value. Now let's solve the opposite problem. Instead of finding the highest marks, suppose we want the lowest marks. Python provides another function called min. Let's write min instead of max. So min marks. The output should be 10 over here. Let's see. Yes. Very simple. Max returns the largest value while min returns the smallest value. Let's quickly compare them. Now, if I change my marks list, that is 45, 89, 73, 91, 67. If I write max marks and then print minimum marks, let's see the output. The output is 91 and 45. So one returns the highest value, the other returns the lowest. Now let's imagine the class teacher wants to know the total marks of all students. Can we do this? Yes. We could write 75. We could write 45 plus 89 plus 73 plus 91 plus 67. But this becomes impossible when hundreds of numbers are involved. Python gives us another useful function, that is sum marks. So the output is 365. Let's understand this carefully. Python adds 45 plus 89 plus 73 plus 91 plus 67 and finally returns 365. This is much easier than writing every addition manually. Now let's revise all four functions together. So the first one was len. Then the second one is max. The third one is min. And the last one we understood was sum. Now let's see the output. The output is 5, 91, 45 and 365. Now you can easily remember that. Len, number of elements, max, largest value, minimum, smallest value, and sum, total of all values. Now let's build a small project using everything we have learned in this lecture. Imagine you are creating a shopping list for your family. Initially, the shopping list contains 3 items. Let's write that code. So shopping is equals to milk, then bread, and then rice. Now let's print the original list. Now if I run it, everything looks fine. Now suppose your mother remembers that you also need eggs. Should we create another list? No. We will use append function. Now shopping dot append eggs. Now another item needs to be added at a specific position. Let's insert butter after milk. So after milk is the first position. So we will use the insert method. Shopping.insert 1 comma butter. Now suppose bread is already available at home. Let's remove it. So shopping dot remove bread. Now the family wants the shopping list arranged alphabetically. So let's sort it using which function? Correct. Sort function. Now finally let's print the updated list. So print shopping. And finally the output is butter, eggs, milk and rice. Now let's find the total number of items. So we will write print len shopping. The output should be 4. And yes, we get 4. Now this is a very small project. But you may have noticed something that in just one program we have used append, insert, remove, sort and len. This is how real programs are written. They combine multiple concepts together. Now, I would like you to pause the video and solve these questions without looking at the solution. So the first question is, create a list of your 5 favorite foods and sort them alphabetically and print the final list. The second question is, create a list containing 10 numbers and then print the largest number, smallest number, total sum and the total number of elements. The third one is create a shopping list, add 2 new items, remove 1 item, reverse the list and print the final result. And the last but not the least one Create a list containing duplicate values. Count how many times one value appears. Now try to solve these questions before watching the next lecture because we all know programming is a practical skill. The more you write code yourself, the more confident you will become. Now let's quickly revise everything we have learned throughout today's lecture. So, at the first part of this lecture, we learned what a list is, how to create a list, positive indexing, negative indexing. Then we learned list slicing, updating elements, append, insert, remove, pop. And finally, we learned many methods like sort, reverse, count, index, copy, clear, len, max, min, and sum. That means you know how almost ev- now that means you now know almost every important list operations required for beginner and intermediate Python programming. So congratulations, you have successfully completed one of the most important topics in Python. Lists are used in almost every real world applications. Whether you are building websites, creating games, analyzing data, or developing machine learning application. So don't just watch this lecture once. Type every program yourself. Change the values, experiment with different inputs. The more you practice, the more comfortable you will become with Python. So in the next lecture we will move on to three more important Python collections, that is tuples, sets and dictionaries. Thank you for watching and I'll see you in the next lecture.